All right, so we've talked a little bit about this kind of leading up to it. It's the opposite of derivatives. So the whole second semester is on antiderivatives. So once you know derivatives, antiderivatives are much easier because it's just the opposite. So it says, suppose you know the velocity and you want to know its position, so like the distance it traveled or anything like that. Or maybe you know the rate at which a population is increasing, but you want to know the actual population. So in order to do this, we need the opposite of derivatives, which are called antiderivatives. So you guys have kind of seen this. It's been a few weeks since you saw it, right? Second semester or first semester. So this is going to be kind of familiar to you. It's also going to be related to the area stuff that we've talked about before. So it says we usually denote the antiderivative of a function f of x with the capital letter F. We've done that before. So it says if we want to notate that we're finding the antiderivative, we use an integration sign, which looks like an elongated S. You'll often hear the term integrate instead of find the antiderivative, so it means the exact same thing. So when you see something that looks like this, it says integrate 1 over x cubed. The dx, like I said before, is just associated with the elongated S. It just goes together. Okay, so you're going to rewrite it, so you're going to have x to the negative 3 dx. Okay, so if you remember when we did our antiderivative, we add 1 to the power. So we're going to have negative 3 plus 1, so negative 2. And we're going to have 1 over that new power. So 1 over negative 2. And then we always do a plus c. So you get negative 1 over 2x squared plus c. You could also just leave it with the x to the negative 2. It doesn't bother me. All right, so the next one is really the x to the 1/2, right, dx. So we add 1 to the power. We write 1 over the new power. So if I have 1 over 3 over 2, it's going to be 2/3 plus c. And then just like our infinite sum, we can pull a 2 out to the front and then just integrate sine of x, right, just like the sigma. So we're going to have 2 times, if I integrate sine, what do I get? Close. Negative cosine, right? So be careful. It's not the derivative of sine, it's the antiderivative. Oh, I shouldn't do the x. Sorry. Plus c. So it's negative 2 cosine of x plus c. All right, next up, so the power rule for integration. So this is what we talked about. So if we have f of x equals x to the n, so I'm integrating x to the n, then what we are doing each time is we're adding 1 and we do 1 over the new power. And then we always tack on a plus c because we know that if we take the derivative of a constant, it's 0, so it could have had any constant at the end. Okay, so be really careful. If I give you a bunch of antiderivatives, make sure you go back at the end of the test and look for your plus c's. Okay, it says we also made the stipulation that n could not be negative 1. So think about that. If I have x to the negative 1, right, as my derivative, what was my original function? What gives you a derivative of 1 over x? Natural log, right? So that's why we made that stipulation, because if we have natural log, then its derivative is 1 over x. Okay, we also talked about differential equations a little bit before, so let's kind of review those quickly. So if I have f prime of x equals 1 minus 6x and f of 0 equals 8, then if I take the antiderivative, I get x minus 3x squared plus c. It's hard to do at first, isn't it? All right, so I have 8 is equal to 0 minus 3 times 0 squared plus c. So I get 8 equals c. So my function is f of x equals negative 3x squared plus x plus 8. You don't have to write the negative 3x squared first. It's just a lot of people are picky and like to see it that way. All right, so the next one, I have f of x equals x to the 5 over 2. I'm going to have a 2/5 out front. And then I have plus c. So when I plug in 1, I get y equals 2. So I have 2/5 plus c equals 2. So I can rewrite 2 as 10 over 5. And then subtract the 2/5 over. So I get 8/5 equals c. So is all this reviewed? Do you guys remember all this? So I get f of x equals 2/5 x to the 5 over 2 plus 8 over 5. Anya?
Where's the simplest one?
Because I wrote 2 with a denominator of 5. I multiplied by 5 over 5. Can I flip? Are you good? Okay, so same thing on the next one. You could have to do the first and second. Like you could have the first and second derivative. So I have f double prime of x equals 20x cubed plus 12x squared plus 4. So f prime, I'm going to have x to the 4th. I'm going to put a 5 out front. It's 20 times 1/4. Then I have plus 4x cubed, right? Plus 4x plus some constant. So I'll call it c. Okay, but on this one, I don't have anything that has f prime. So we've done these before where I've given you f prime of 0 or something, and I've allowed you to find what c is, but we can't actually find c at this point. So now I have to do f of x. So I get x to the 5th plus x to the 4th plus 2x squared plus cx plus d. Are you guys all good on the antiderivatives? Do I need to go slower on that? Or do you guys understand? Yeah. Remember what we did before is we did 5, and then I did x to the 5th with a 1/5. If you need to see the fraction, then I have x to the 4th with a 1/4. Yeah. So if you have some constant, then it's going to be c times x. Okay, so now I have 2 things. I have f of 0 equals 8, and I have f of 1 equals 5. So I'm going to have, when I plug in 0, I get 8. So I have 8 equals 0 plus 0 plus 0 plus 0 plus d. So right away I get d equals 8. And then f of 1, so f of 1 equals 5. So I'm going to have 1 plus 2 plus c plus 8, right? D was 8. So I have 5 equals 4 plus 8, so 12 plus c, so c equals -7. So your final function is f of x equals x to the 5th plus x to the 4th plus 2x squared plus cx minus 7. Or not cx, what am I talking about? Squared, let's see. Minus 7x plus 8. There we go. Okay, so you guys kind of remember those? We did those first semester. I think they're on your final too. All right, so you might also have some like story problem type things. So it says a car is traveling at 73 feet per second. So recognize that that's a velocity, right? But it's really just the initial velocity. So I'm going to put v sub 0. So I remember that it's maybe not constant velocity. It's not always the same. When the brakes are fully applied, producing a constant deceleration. So that one is constant. And since it's a deceleration, I'm going to make it negative. So I'm losing 22 feet per second squared. So negative 22 feet per second squared. What is the distance traveled before the car comes to a stop? So I have my acceleration. So a is negative 22. If I want my position, I'm going to integrate. So I get negative 22 t plus c. Not position, velocity. Man, I'm struggling today. Velocity. Okay, and then I do it again to get the position. Okay, what is c in this case? Yeah, it's the 73. Do you guys see that if I plug in a time of 0, right, I get a velocity of 73? So it basically solves for c. C in this case will always be like your initial velocity. So we have v equals negative 22t plus 73. All right, so my position, which we often call s, is going to be negative 11t squared plus 73t plus d. And d sometimes they'll give you, especially if it's like a up and down problem, that they'll say like, you're jumping from a building that's 20 feet high or whatever, you know. But usually if it's like one of these car problems, they don't really have like a starting position, so we make it like position 0. Okay, so this is going to be d equals 0. So just starting at the starting line. Okay, so the question is, we want to know how long it takes before the car comes to a stop. So what am I going to do? Any ideas?
C equals 0.
Set what equal to 0? The velocity, right? You want to find when the velocity is equal to 0. So we're going to do that. So I'll do it over here. So I'm going to set my velocity equal to 0. So I have 0 equals negative 22t plus 73. So I subtract my 73 over, and then I divide by a negative 22. So I get positive 73 over 22. Because I have negative divided by negative. And then I want to find how far it's traveled. So it started at d equals 0. And then I want to plug in 73 over 22 into the position function. Right? So I'm going to have 7 s equals negative 11, 73 over 22 squared plus 73 over 22. And that's kind of like your distance equation, your position equation. Just from that. 121.114. It's from right here. It's the antiderivative of the velocity. It's your position equation. Okay? All right, and that would be in feet. So your answer is feet. All right, so number 5. So a ball is thrown upward with an initial velocity. So again, that's like a v sub o. It's not like a constant velocity the whole time, feet per second. From the initial height, so I'm going to call that h sub o, of 80 feet. Use the fact that gravity is approximately negative 32 feet per second squared. So that's going to be your acceleration, negative 32 feet per second squared. And you can always tell from units, remember? This probably always says units are the key to life. So it's acceleration is feet per second squared. Feet per second per second. So if you want to find the position function, you're just going to keep doing the antiderivative. So I have my acceleration. If I do my antiderivative, I get my velocity, so negative 32t plus c. What's my c? 64, it's the initial velocity. Because if I plug in times 0, I get a velocity of 64. All right, then I do the antiderivative again. So my s is going to be negative 16t squared plus 64t plus some new constant. So you can call it C2 if you want, or I usually call it D. What's D in this case? Nope, not 0 this time. It's 80, because if you plug in a time of 0 for all of these, right, you get a height of, I guess I should do H, or call this S sub O, just to be consistent. I get a height of 80. So that means D has to be 80. See how that works? So whatever you have, like whatever, if you're on S or V or whatever, that constant is always like your initial height or position or whatever.
Why is 80 set to equal the equation? Equals 80?
Because it's saying the initial height of 80 feet. So at time 0, when t equals 0, your height, or S, equals 80. So that's what we did. We plugged in 0. All that was gone. You got D equals 80. So you're just solving it all out. So eventually you guys will get to the point where you just know that that last thing is your initial height. That's what I was saying. So I get negative 16t squared plus 64t plus the initial height of 80. Okay, so that's your position function. Okay, so the next one says, when does the ball hit the ground? So what am I finding if I'm finding when the ball hits the ground? Yeah, when it equals 0, right? When the height, or the S in this case. So I set it equal to 0. I think I made it so this one factors. So I'm going to pull out the negative 16. I'm going to have t squared minus 4t minus 5. So I get t minus 5 and t plus 1. So I get t equals 5 and t equals negative 1. Okay, so this is time. This is in seconds. You can't have negative 1 seconds. That basically means you're already on top of the building. If you could go back in time, that that ball would have traveled backwards. It took 1 second to get up to the top of the building, I guess. All right, so your answer is 5 seconds. That's how long it takes. If you're standing like on a platform or something, yeah. All right, now these are the ones that really trip AP Calc students up. Don't make them harder than they really are. Same with derivatives. When I asked you to take derivatives of things like this, you guys were like, what? Let me do quotient rule and chain rule. Don't do quotient rule and chain rule. Okay, now it's a little bit more straightforward with integration because you can't do it in the first place, right? It's like, wait, I can't do a quotient rule or a chain rule. All right, so in this, what I'm going to do is I'm going to rewrite. I'm going to have x plus 1 over x to the 1/2. And I'm going to take that x to the 1/2 into both pieces. So I'm going to have x divided by x to the 1/2 plus 1 over x to the 1/2. So I can subtract my powers. So I'm integrating x to the 1/2 plus x to the negative 1/2. Much easier this way, right? 1 minus 1/2 is 1/2. I see you confused. No.
Oh, just kidding.
It's like x divided by square root of x. I see a lot of confused faces. This is what's happening. Right, the top is square root of x, cancel, cancel. Right, you get square root of x. All right, so anyway, so I have add 1 to the power. I have 2/3 out front. Add 1 to the power. I get the reciprocal, 1 over 1/2, so I get a 2 out front. Plus c. All right, try the next one. Right. You leave it as, yeah, plus c. So 1/5 x to the 5th minus, so I'm going to bring the x squared into both pieces. So I'm going to have 4x squared plus 3, no wait, minus 3, be careful with your sign, minus 3x. You see where I got the minus? Yeah, because it's like that whole numerator was in parentheses. You're subtracting out the entire fraction.
Where'd you get the 1/5?
If you have x to the 5th over 5, it's the same as 1/5 times x to the 5th. You can think of it as x to the 5th over 1. Like you can break it apart. All right, so now you're ready to integrate. So you get x to the 6th. You would have a 1/6, but you also have that 1/5. So I'll do it one thing at a time because I think some of you guys are still in trouble with this. Minus x cubed. I'm going to have a 1/3 and a 4. X squared, I have a 1/2 and a 3. Oops, I don't know what I did print there. Plus c at the end. So I get 1 over 30, x to the 6th, minus 4 over 3, x cubed, minus 3 over 2, x squared, plus c.
How are you getting the 1/6 and
When I'm integrating. So I'm trying to break it up apart so you can see it. Like remember how if you have like x to the 7th, you add 1 to the power and you have a 1 over 8 out front. I'm doing that so you can see it like each time. But I still have the numbers from before. So if that's easier for you, you can do it that way as well. You need to see the two steps. Especially with fractions, sometimes it's easier that way. All right, does it make sense? All right, so be really careful. Don't like look at these integration ones and they look complicated and you're like, I don't know how to do this. Like think about how you can bring the denominator in and you can make it look nicer before you do the antiderivative. All right, so what about something like this? So we have sine of x over cosine squared x. Well, it doesn't look super familiar right now. We know it's going to be like a derivative that we know, right? Something that we've learned from our derivatives drills. But it doesn't look like something we know from our derivatives drills right now. So let's try to move it around. So this is why you had to do all those identities when you were in pre-calc. So what if I have like sine divided by cosine and then 1 over cosine? What if I break apart the cosines? Does that help?
Yeah.
What do we get? Tangent times secant. So we have secant x tangent x. What gives me a derivative of secant x tangent x? Secant x. Right? Secant x has a derivative of secant x tangent x. Okay, so see why I make you like memorize all of those different things, because you're going to have to see it in places like that. It's a little bit hard when you see it as sines and cosines and so on. All right, well, what if we have something like this where we have something squared? How do we do the antiderivative? There is an anti-chain rule. We have not learned it yet, though. Like multiply it out? Yeah, we're going to multiply it out. So yes, Blake's noticing that, like, when we get things like this, that's not going to be so fun. Like, there has to be something that's the opposite of the chain rule, and we will learn that. It's called U substitution. But for now, we don't know it, so we're going to go ahead and multiply out. So I'm going to have 4x squared minus 12x plus 9 dx. So I'm going to get x cubed. So if I write the 1/3 out front, remember, don't forget your 4. So 4/3 x cubed. I'm going to have my x squared with 1/2, so I'm going to need a 12 times it. And I'm going to have 9x plus c. So I'm going to have 4/3 x cubed minus 6x squared plus 9x plus c. Okay, so the whole question is, like, how are definite integrals related to area? So most textbooks make you wait a really long time before they tell you, but it's the antiderivative. It's the same thing, integration. The more practice you have with this, the better. So if you have the integral from a to b of f of x dx, it's equal to f of b minus f of a, where f is the antiderivative. Okay, so if I have something with numbers, it's representing an area on a certain interval. Okay, well, we talked about the integration, like the 1 to 3 type thing. Okay, so what I'm going to do here is I'm going to do the antiderivative of 6x squared. What do I get when I integrate that? 2x cubed. So I'm going to write that. And instead of doing a plus c, I don't need it. I just leave it off. And I go from 1 to 3. I do a little line, 1 to 3. I'll tell you why you don't need it in just a second. Okay, now I'm going to plug in 3, and I'm going to plug in 1, and then I'm going to subtract the two values. So I'm going to have 2, I'm going to have 3 cubed, minus 2, 1 cubed. Okay, don't miss this, guys. This is important. So I have 2 times 27 is 54 minus 2, so I end up getting 52. Okay, so the question is, like, why do we not need the plus c? If you had the c, I mean, it works the same way. It's just kind of like extra stuff. You don't need it, because what I would do is I would plug in the 3 first. So I'd have 2 times 3 cubed plus c. I'd find that result, and then I'd subtract out what I got when I plugged in the 1. So what happens? Well, I get the 54 plus c, and then minus the 2, minus the c. Do you guys see how the c's go away anyway? So it doesn't matter.
You take the antiderivative and plug it in the top.
You plug in the top number, and then you plug in the bottom number, and you subtract your 2. Okay.
It is negative.
No. You would still just plug in the negative number, right, and then subtract. Okay. Basically, what's happening is it's like if you have some kind of function from a to b, and you're finding from 0 to b, you're finding that area, 0 to b, and then you're finding the area from 0 to a, and then you're subtracting the 2. So do you see how, like, when you subtract out the big area minus the smaller area, this area, you end up getting the part that you want. Okay, so you're finding the a to b part. So we just don't do the 0 part. Okay, next up. So if I have sine of x, the antiderivative of sine, you're just going to say cosine every time, aren't you? Okay, so that. So I'm going to have negative cosine of pi minus a negative cosine of 0. Again, unit circle is important. I'm going to have pi is over here. What's the cosine? No, -1. So I have -1 minus a negative cosine of 0, 1. Lots of negatives, so be careful. So 1 plus 1, so I get 2. So choose your answer. Okay, so basically the thing to remember is when you have an indefinite integral. Indefinite means that you don't have numbers on your integration sign. So if you just have the little squiggle, and you don't have a number here, and you don't have a number here, like you don't have numbers at all, you need a plus c. But if you have numbers, you don't need a plus c, because it ends up going away. Okay? All right, so this one. So I'm going to integrate, so I have x squared. I'm going to get x cubed with a 1/3 minus 4x, and I'm going to go from 0 to 2. I'm going to plug in the 2, so I get 1/3, 2 cubed minus 4 times 2. I got lazy. I started to not write the 0 part. I should probably do that for you guys, right? So I'm going to have 1/3, 0 cubed. Do you guys see why I almost didn't write it? Yeah, it just goes away. It's just 0 anyway. But that's not always true. Like, what if you had cosine of 0? That didn't go away, right? So you got to be careful. All right, so I get 8/3 minus 8. So I'm going to have 8/3 minus, if I get common denominators, 24 over 3. So I get negative 16 over 3. So this one's negative. It can be negative. Okay, integration, like an integral can be negative. Okay, when I ask you to find the area under a curve, then that's usually where you have to say, oh, it's trapped by the x-axis and the curve. Okay, so it can be negative. All right, we'll stop there.